This is a recording of a physics experiment developed for Minecraft. I've used the MinecraftEdu mod, which you can see here. So what this allows me to do is bring up my own world that I've created, save a map, have some control over students, and so that's what I'm using here. To save a map, you just push that button. But I'll just show you the model. So I have this big tower, and what I'm doing is I'm dropping things from the top of the tower, and they fall down. They activate these tripwires. The tripwires then send a message, a redstone signal, to these computers in Computercraft. Then when they receive the signal through the wireless router, they send a message to a master receive computer that I have like up in the middle of the tower. And what that does is it records the time, and it has the information about the height for each computer. You can also see here that I have redstone lamps, and so when these tripwires are activated, there's also a signal that goes to these redstone lamps, so you can see where the object is falling. So let's just take a look at at my different computers. We'll just go up, and I put the receive computer in the middle of the tower so that I could receive signals from the top as well as the bottom, just to make sure we had enough range. This is my send computer, so we'll look at the file that sends the message to the master. It opens the wireless communication at the top. It gets the information about itself. What computer is it? It sets just a local variable master equals 0. It then does a pull event, and it tests whether the pull event is a red net message or a redstone message. If it's a red net message, that means it's getting a broadcast message from the master computer, and it's telling it, hey, send your message to me, the master computer. If it's a redstone message, and then it's looking to see looking to see if it got a message from the left-hand side, or a redstone signal from the left-hand side. And if it did, then it's sending a message to the master. And what happens in the master is that it detects that it received that message, and then it writes information to a file. And then just for debugging purposes, this computer also writes to its screen, and it says on computer, gives it its ID, and it says I'm sending it to master computer, and it gives it that information. So that's that. So I can run, I have a little startup program that calls that other program. So now this is running. Now here is my master computer that receives the signals from all the computers here through its wireless modem here. So let's look at its program. It has a table here with height information starting at the top, 0, and then going down. So it's going down and increasing in height, so starting at 0 and going down. And so what this does is it opens the communication at the top. It gets information about itself, what computer am I, and then it broadcasts that to all the other computers so they know which computer to send it to. The reason I did that was because I kept destroying my master computer, and instead of having to enter it into all the other computers, I just had a broadcast. It asks you what name you want to save your information, your data to, and it opens that file. Then it looks for an event, and if it's a rednet message, then it checks to see if my rednet message, if the sender ID is the top, this 82 is the topmost one, it sets the start time to that time, so it tests for the clock what time it is, and it writes it here. If it's some other, from some other computer, it detects the clock time and then subtracts the start time, so it gets the time from when it began to the time that it's detecting now. It looks in the table up above for the height based on the computer ID here that it got the message from, and then as a for debugging purposes, it prints this information to the screen, and then it also writes to the file here. So it does the sender ID, the time from this calculation here, and the height from the table. And then if there's a button at the bottom, and if it's pressed, then it closes the file and it breaks out. So here we'll get out, and we'll do another startup that starts my command, and I'll call this sand. So the file where I'm storing the data is called sand. Here's my button when I need to break out so that I make sure I save my data. I push that. I'll go up to the top, and we'll run a few of the experiments. here we can see down the ways a bit. So I'm dropping the sand. You can see that falling. Takes about 4 seconds. And I can drop another, so I can do, say, 10 tests if I want to, right from up here. Do one more. And now if I go in here and I look at my computer, I can see here that my computer's telling me I'm 82 and I sent a message to 62. So that's what I wanted to see. And now I'm going to go down a little more to my receive computer. This is my receive computer. So I just stopped it. So now it's saved the file. And I look in here and I can see it's written my information. Now if I want to go out, my data is written. Here. Well, first what I have to do is I need to go to my server and save the file, save the world, otherwise my file won't be saved. So now that I've done that, I can go here to my world, go to physics world, go to computer, that's where all the computer information is stored. Go to computer 62, I can look at sand, here's my data. And so I have my multiple runs all right here. And then here's an example when I just brought it into Excel of here's some data that I have from an earlier run where I only had a few computers doing the testing. I don't have all of them in this example. But you can see I can plot my data here. And I used a polynomial, so I can use the y equals 1/2 a t squared plus vt plus x, or plus y, sorry, why not? And this will tell me my 1/2 a, this will tell me my acceleration here, and I can compare these two for, think about a starting velocity and a starting height. So that's it.